Okay. Good morning, good afternoon, good evening, depending the time you are seeing this video. Okay. Today we are going to talk about chemistry, and I will be very brief because you can see I have no board, so I'm just gonna explain one or two things for those who are writing WAEC. It will help you a lot. Yes. So just listen attentively. I won't rush you. Just a brief explanation on what rate of chemical reaction. Rate of chemical reaction. Okay, first of all, when you hear a chemical reaction, just know that a chemical reaction is what is a reaction that brings about a permanent change because of what chemical changes. So just when a reaction takes place, just know that what the particle has what collide with one another. That's one of the main thing you just have to bear in mind as what as a sense that chemical reaction takes place when the what particle collide with one another. So for now, just know that. Then what is the rate of chemical reaction? Rate of chemical reaction is the speed of what reactant particle conversation or product formation. Let me explain this. The rate of chemical reaction is all about the speed, the velocity, let's say the speed of what of a reactant to what to be converted to product, or a product to be what to be formed. That's what the rate of chemical reaction. Then we have what we call the collision theory. Yes, I have a lot to explain in collision theory, but I will take it step by step. First of all, what is collision theory? The collision theory says that for a chemical reaction to take place, the reactant particle must collide with one another. That's one of the main things you need to know about collision theory. Then we have what we call the effective collision and the activation energy. You know that I say that collision theory is a situation, or before a chemical, it said that before a chemical reaction to take place, the reactant particle must collide with one another. So that's one the collision theory. Then I say that we have effective collision and what activation energy. Let me explain this. Effective collision, before a chemical reaction to take place, it must collide with one another. That's what the collision theory says. But that collision won't be an effective collision. It must have an effective collision. If it doesn't have an effective collision, it can't take part in a chemical reaction. So that's the main definition of what effective collision. The collision that makes a reactant take part in a chemical reaction. So that's the main thing you need to know about effective collision. Then we have what we call the activation energy. Activation energy. What is activation energy? It is the minimum energy a reactant particle must contain. The minimum energy a reactant particle must contain in order to take place in what in a chemical reaction. Okay, let me explain this. And a reactant particle must possess an energy that equals or what or more than what the activation energy. The reactant particle must possess an energy that equals the activation energy, or more than what the activation energy, before it can take part in a chemical reaction. So this is very simple, just understand it. Then we have things that makes a rate of things that helps a chemical reaction to take place, and we have things that does not that affect the rate of chemical reaction, that things that stop a chemical reaction from taking place, which I will explain in this video. Okay, things that help the rate of chemical reaction to take place. One is what the collision theory. You all know that the collision theory says that for chemical reaction to take part, the reactant particle must collide with one another. So it's one main example of things that helps a chemical reaction to take place. That's the main thing. Then what? The second one is what activation energy. What is activation? I've explained it. Is the minimum energy a reactant particle must possess. So if a reaction must take part, it must the reactant particle must obtain an energy that is what equal or more than what the activation energy. So activation energy helps what to make a chemical reaction to take part, to make a reactant to take part in a chemical reaction. So okay, now we have things that makes a chemical reaction not to take place. Okay, number one is what when the reactant particle does not collide. When the reactant particle does not respect the collision theory. When the reactant particle does not respect the collision theory. If the reactant particle doesn't collide, chemical reaction will not take place. That's the major thing you need to know. Then what? Number two is when the reactant particle does not possess the energy that's what equals the activation energy. If the reactant particle, let me explain this. If the reactant particle possesses an energy, but it doesn't equal the what? The activation energy. Or let's say if the reactant particle has an energy that is what? Below the activation energy. That's when the what chemical reaction will not take place. That is. Then the second one is the steric hindrance. Note this, the static hindrance. Whenever you hear static hindrance, one thing should come into your mind, that is a situation whereby the shape of the molecule of the reactant particle, it's the effect that takes place when the shape that consider the shape of what the molecule of the reactant particle. Let me explain this. In a reaction, if the reactant particle is affected by what the shape of what of the molecule of the reactant, know that is what is a static hindrance. So this is very simple. Just try to understand it. Then now we came into what the factors affecting rate of chemical reaction. We have factors affecting the rate of chemical reaction, which I will explain very well in this video. So before I proceed, when you see this in my channel, please try to subscribe to my channel, like my video, share to your friends. It will help you. It will help you in life, especially for SS1, SS2, SS3 students in secondary school. It will really help you, especially those preparing for what WAEC. Yeah, very soon I will start doing revision for what WAEC, both physics, chemistry, and biology. Just stay tuned to my channel. So there are factors affecting what the rate of chemical reaction. First of all is what nature of reactant. Let me explain this. Nature of reactant is when, okay, let me explain this. When ion react with what hydrogen, hydrochloric acid. When ion react with hydrochloric acid, its rate of chemical reaction is very low. Why? Because the evolution of what hydrogen is slow. The evolution of what hydrogen is what slow. So, but when a zinc reacts with ion, the rate of chemical reaction is very high. Because of what the evolution of what zinc is what high. So the nature of what of the reactant particle can affect the rate of chemical reaction. This is how it works. That's why they say what the nature of the reactant particle can affect the rate of chemical reaction. Now we have what the surface area. The surface area can what the surface area of the reactant. It can affect the rate of chemical reaction. Let me explain this. In a situation that a reactant gas is a reactant particle, which is gas, is reacting with a reactant particle which was solid. If the surface area of the solid is what, like let's say if the surface area of the reactant is solid, the rate of the effective collision will be slow. But if the surface area of the reactant is being breaking down into powder, then it reacts with gas. Just notice that, for example, a dust. When a dust, you see that a dust is what the mixture of what air and what and sand particles, which is what in powder form. So you see the effective collision is what is high. So the surface area of a reactant can what affect the rate of chemical reaction. So that's it. Then we have what? We have the pressure and what concentration. Pressure and concentration. I will start with what concentration. Remember, okay, I haven't dropped this video, but I will drop about acid, base, and what? Salt. Just know that acid, when an acid is what is being put in a small quantity of water, instead of the acid is what highly concentrated. Acid is what highly concentrated. So when the higher the concentration of what of the reactant particle, the higher what the rate of chemical reaction. That's very simple. The higher the reactant, when the reactant particle is what is highly concentrated, the effective collision what increases. Yes, it increases. So that's the main thing you need to know about concentration. Then pressure. Mostly pressure takes place more in a reactant particle that is called gaseous. Because you know that in the gaseous theory, you see that the higher when the let's say let me explain it this way. There's one law in gaseous theory. It says that the molecule of the gas react or collide with one another with the walls of the container at what high pressure. So the higher the pressure, the higher the effective collision. So the gaseous particle collide with one another at high pressure with the walls of the container. So the effective collision increases in high pressure and decreases in low pressure. I hope you understand. This is very simple. Just calm down and understand. So we have the another one which is what? We have the light. Light can affect the rate of chemical. Okay, let me note this. Any reaction that light affects is called photochemical reaction. Photochemical reaction. Just note it. Any reaction that light affects is a photochemical reaction. Let me explain this. And a reaction that light affects is a photochemical reaction. For example, now you have what the combination of methane and chlorine. Methane and chlorine is what is a photochemical reaction. It's association of what hydrogen peroxide. Yes, it's association of what hydrogen peroxide. Then we have what we have photosynthesis, which I explained in my last in my last video, photosynthesis is a photochemical reaction. It affects by light, which is the light reaction of photosynthesis, which I explained. If you didn't understand, you can go to my last video where I explained the light reaction in what photosynthesis. Watch it, you understand it very well. Okay. Now we have what you call another factors affecting rate of chemical reaction. So temperature. Yes, temperature affect the rate of chemical reaction. Okay, let me note this. The average kinetic energy of a gas is what equals what? The absolute temperature. So if the kinetic energy depends on the temperature, that means the higher the temperature, the higher the effective collision, the higher the rate of what? Chemical reaction. Then the lower the temperature, the lower the rate of chemical reaction. Then you have what? Catalyst. I will be very brief in this one. You all know that catalyst is what? Mostly inorganic or organic. Organic catalysts are enzymes. You have inorganic catalysts are mostly chemicals. Yes, those know that organic catalysts are what? Enzymes, and inorganic catalysts are mostly what? Chemicals. So catalyst is speed up the rate of what? Rate of chemical reaction, but it become chemically unchanged at the end of what? A reaction. So okay, note this. The main function of a catalyst is what? Is speed up the rate of what? Chemical reaction. Then just know this and what I want to say now. Any catalyst that reduces the activation energy is a positive catalyst. And any catalyst that increases what? The activation energy is what? A negative catalyst. Remember, any catalyst that reduces the activation energy. We all know what is the activation energy. Any catalyst that reduces the activation energy is what? Positive catalyst. But any catalyst that decreases the activation energy is what? Negative. Sorry. Any catalyst that increases the activation energy is a negative catalyst. Yes, and any catalyst that reduces the activation energy is a positive catalyst. So as you all know now, that rate of chemical reaction is what? Is the speed of what? Reactant composition and product formation. I really appreciate those who stay to the end of this lesson. I hope you will learn a lot. Then in my next video, I will drop on what types of what reaction, and I will explain it to the way you would understand it without any doubt and any problem. I wish you the best, and also subscribe to my YouTube channel, like my video, share my video to your friends, to well wishers, anyone, even your classmates in school. Yes, because I'm mostly a student. So your classmates in school, you can share it. It's very important for those preparing for WAEC, okay, and those for SS2 and SS1. It will really help you. I really appreciate it. Thank you so much.